So last thing we want to do here in chapter 7 is find area of triangles. So you guys have done finding all the sides of the triangles. We know how to find area of a right triangle, just 1/2 base times height. But since we've been able to find angles and sides for all these triangles that aren't right, we might as well look at how we do area as well. Here's a simple little proof for it. This is a good extra credit question as well, because the formula is pretty simple to come up with. So we take our basic triangle that's not right, like this. We label a couple things. We throw in the height here, okay? And all we're going to say is we know area of a triangle is 1/2 base times height. So if we do a little substitution here for h, and we say, okay, if I take this lambda, I got an opposite, so I'm going to use a sign for that. So I'm going to say sine of lambda equals opposite of h over a, and I multiply across by a. I can take this, throw it right in there for h, and I've just created a new formula that lets me do this for any triangle. So again, there's going to be 3 different forms, because it all matters what we're given, so what we can work with. So area of a triangle, 1/2 the product of its 2 sides times the sine of the included angle. So that's the key. So I gave you side A here, I gave you side B, this is the angle included in it. Okay, so you got to make sure that all those guys are in a string there. You don't want to use this angle down here. Okay, so here's the formula. We'll take a look at it. So 1/2 AB sine C, 1/2 AC sine of B, okay? 1/2 BC sine of A. So whatever 2 sides you have, you'll have the opposite angle. So if I give you sides A and C, you have sine of B. Sides B and C, you'll have sine of A. So whatever's missing. So again, you'll have the formulas, you just have to make sure we're using them correctly. Simple little example here. We'll do some story problem stuff in class. Area of a triangle, A is 5, C is 7, beta is 70. So we match it up with our formulas here. I give you A and C and sine of B. So we can use this guy here. And we just go right to our calculator and see what happens. So when we do that, 1/2 2 sides in the included angle, we get 16.4. Now since this is area, make sure you have a unit squared on there. If they give you feet, make sure it's feet squared or whatnot, just so we're clear on the units there. Okay, so there's one example with area using one of the 3 formulas, which are really just the same thing. Now, this Haran's formula, that's the same guy from the video we watched the other day. He's also known as Heroes. Okay, so he did that work where they put the tunnel through that mountain, and he talked about the north-south distances and the sum of the west distances, so they could use similar triangles and get that water through the mountain without just having to guess here. So he also did some other stuff with triangles, obviously, and this is what he came up with. So if I give you the 3 sides of a triangle, we can find the area. Okay, if I give you the 3 sides, you could go do law of cosines to find one of the included angles, and then you could go use one of these guys. Okay, but if we want to take one step in between, we should be able to use this. Now here's the formula. Square root of an s, s minus a, s minus b, s minus c. S is basically this, 1/2 times the sum of all the sides here. So we take the 3 sides, we add them together, we cut them in 1/2. That's going to be our set value for s, and then we just plug them right into this formula here. Okay. The proof for this one's a little bit more complicated, so if you want to see it, I encourage you guys to look at the very last page of 7.4 in here. I'm just going to briefly talk about it. What they do is they kind of start with this cosine squared half angle thing down here that we've looked at before. So remember, cosine of a half angle is actually the square root here, the plus minus. So they've squared both sides, so it's back to here. Now what they do here for cosine of lambda is they do a law cosine substitution. So we would have so they solved this guy for cosine, so they move all this stuff away, all that. They would throw that guy in there, and they would go through. They'd do the exact same thing for sine. Sine squared of lambda over 2, whatever, and you can switch the angles around, and you do a bunch of work, and it comes out to these two things right here. So all we have to do is be able to use them, but it wouldn't hurt to look at that proof. It's just a little bit tougher than the other ones we've been doing. Okay. So a simple problem would be something like this. So area of a triangle, sides are 5, 8, and 11. We don't know if it's a right triangle or not, so we can't just say half base times height. You try and use one of these formulas. You don't have one of the angles. Okay, yeah, you could do a law of cosines to find one of the angles. You could assign these things, you know, A, B, and C. You could go find one included angle and use that. Or you could just use Hero's formula. And I'm just going to show you the work here, because it's basically just a plug and chug thing. So take your three sides, add them together, cut them in half. Here's your S. Go plug the S in 4 places. So we take S minus the side, S minus the other side, and whatnot. Make sure the order on this is correct. You don't want to have 5 minus 12. We shouldn't have negative lengths in there. We just be careful we do all the work. You can give me an answer like this, or you can spit out a decimal. Either way is fine. Okay, so that's going to conclude everything we're doing in Chapter 7. It gives us a couple days next week to look at some more problems, work on your guys' projects, and get ready for that test.